Good morning, Year 7. I hope that you're well and I hope that you found yesterday's lesson easy to follow along. Thanks for those of you who've sent me your work already. Amazing. So again, before we start this lesson, I would like you to familiarize yourself with these symbols because you'll see them on the slide. So we have the press pause button. Now you know when you see it and I tell you you need to press pause, do the task and then come back to the PowerPoint when you're ready. There's set timer. Depending on how long the task is, you set your timer. When the timer goes off, you finish the task and then you come back to PowerPoint. I would like you to continue to write down your answers on the Word document, please. I know some people have problems with the Word document. If you do it on a piece of paper, take a picture of it and then either attach it to your team's assignment if you can, or email it to me, please. There's a new one, watch a video. There's a few videos in this lesson. You're going to watch the video, then you're going to follow instructions. Then, when you are doing any of the self-assessed work, if you see this symbol, it means self-assessed. It means you need to mark your work. So you need to either mark it in a different colored pen if you do it on paper, or you need to change the font on the Word document so I can see that you are reflecting on your work and you're making improvements. Okay, so we're going to start on a little recap from yesterday's lesson. What color on the pH scale would all these substances be? So just as quick as you can, pause the video and write them down on your whiteboard, please. Okay. So we have the pH scale at the bottom of the screen now. So we have a banana, which is pH 5. This is telling you that it is slightly acidic, actually. So it would come up as a pale orange. Pure water, 7. That is neutral, so it's green. It's neither acidic or alkaline. Drain cleaner. Now this is why drain cleaner and, for example, bleach are very hazardous. Corrosive. If you put them next to skin, they will start to eat the skin, or metal. And you can see it's because they are very strongly alkaline. You have blood. Blood is slightly alkaline. It's not neutral, but it's slightly alkaline. Then you have Coke, pH 3. So Coke is actually quite a strong acid. That's why you shouldn't drink too much, because your teeth are affected by the acid. It corrodes them. Okay, going back to the big question, same one from yesterday. Can colors warn you about hazards? So I want you to just pause the video for about 10 seconds, think about it, and then come back to the video. Okay, so hopefully your answer was yes, because you have the pH scale. Those are colors. They're telling you whether something is hazardous or not. So how do we identify acids and alkalis? We use something called an indicator. So they're chemicals, usually colored dyes, that change color if you put them in an acid or an alkali. It gives you information as to the strength as well. So different colors will tell you, ooh, very corrosive, very strong acid, or actually a very weak acid, safe to handle. Are there any indicators that you know? Have a think back to year 6. Did you do any work on indicators, or do you know any of them? So I'm going to tell you 2 that you are going to use at school. And they're commonly used in all laboratories around the world. For example, a forensic scientist, if they find a sample on the floor at a crime scene, they want to test it because they have no idea what it is. So they would start and go, is it an acid? Is it an alkaline? What pH is it? So you would use litmus paper or litmus solution or universal indicator. So these are the 2 indicators that we're going to learn about today. A little fact as well, pure water is neutral, but so is petrol. And I don't know about you, but I would never think that petrol was a neutral pH like water, because they're very different, aren't they? But it's interesting that their pHs are the same, pH 7. So, what is an indicator? If you ever forget this word, think of the indicator on your car. That's how you think of an indicator. You are telling someone which way you are turning. So an indicator is telling you if it's an acid, alkaline, neutral, and then the strength of the acid and the strength of the alkaline. So you can see here we have the different types. You have universal indicator. See, if you put a few drops of it into a solution, it changes color and it looks like the pH scale, so it's easy for you to compare. Then we have a litmus paper. You have red and blue litmus paper. This changes color depending on whether you put in an acid or an alkaline. And you can actually make litmus paper from cabbage. We'll talk about this a bit later. So now we know it's a chemical substance, which is a colored dye that changes color when it's added to acidic and alkaline solutions. So we're going to talk about litmus indicator first of all. So you can have it as a solution, so a liquid. It turns red if you put a few drops of it into an acidic solution, or it'll turn the solution blue if you put a few drops of it into an alkaline solution. And if it's a neutral solution, it turns purple. So very easy to see, red, blue, or purple. You know exactly what your substance is. But we usually use litmus paper. It's usually more reliable, meaning you can repeat the experiments and you will get the same result again and again. It's accurate. You come as red litmus paper or blue litmus paper. I'm going to show you a table and you're going to see the color changes you can have. So if you have a neutral solution, which is, remember what pH? pH 7. If you have red litmus paper and you put it into the solution and you take it out, the red litmus paper will stay red. Blue litmus paper into the solution, it stays blue. So you know if there's no color change, it stays red, stays blue, it is a neutral solution. What about an acidic solution? So if you have a look at the picture over here, you can see if you put red litmus paper in an acidic solution, it stays red, no color change. But if you put blue litmus paper in an acidic solution, it turns red. So that's already indicating to you straight away, like an indicator, what your solution is. What about alkaline solution? Now, red litmus paper, if you put it into an alkaline solution, it actually turns blue. Have a look over here. So this is sodium hydroxide. This is one of the alkaline solutions that you will use the most in the lab. And you can see they've tested it with the litmus paper and it turns it blue. But if you have a blue litmus paper and you were to put it into the sodium hydroxide over here, it would stay blue, indicating alkaline solution. Now, it's important to say how we say it stays red. It's actually better than saying nothing happens or it stayed the same, because it tells us the color we need to see. If you had to explain to someone and you said, oh yeah, I put blue litmus paper into an alkaline solution and nothing happened, or it stayed the same, the person goes, okay, but they have no idea what color it is. So you want to say it stays blue. Now, what I would like you to do on your team's Word document or on a piece of paper if you cannot access the Word document, but that's only if you can't access the Word document, please. You are going to watch this video. So in the same resource section in which you found this PowerPoint on YouTube, I'm going to leave a link to this video. You are going to watch this video, then you are going to write a method. So a method is like a recipe in science that you can follow to make your own litmus paper. When you write a recipe, think of the detail. You don't just say, put the cake in the oven and then take it out when it's cooked, because it's not giving you a lot of detail. You're probably going to burn the cake or undercook the cake. So in a recipe, you would say you want to put the cake in the oven for 40 minutes at 200 degrees Celsius. That gives a person all the information they need. So that's what you're going to do with your method. You need to put all that information in it. You are then going to get someone at home to read your method and watch the video. And if they can follow your method while they're watching the video, you have done an excellent job at scientifically writing down your method. So what I would like you to do now is pause the video, go to your teams, watch the other video, and then write down your method. Okay, So the next task, again on the Teams Word document. Again, if you cannot, you can do it on the same Word document. Just remember to send me the picture, please. I would like you to answer these questions. If you have a timer, please set it for 7 minutes. Write down your answers. After 7 minutes, press play on this YouTube video and I will show you the answers. You will self-assess or mark and reflect on where you could have improved on. Okay, so pause the video, set your timer for 7 minutes. Okay, so let's go through these questions. What is an indicator? An indicator is a chemical substance or dye that changes color when it is added to acidic or alkaline solutions. What is the difference between a litmus indicator and a universal indicator? So you could try and have a go at this question already now. So a universal indicator will tell you how acidic an alkaline a substance is, but litmus paper will only tell you if it's neutral, acidic, or alkaline. Number 3, complete the table to show what color change will occur. So in an acidic solution, blue litmus turns red. In a neutral solution, red litmus stays red. And in an alkaline solution, red litmus turns blue and blue litmus stays blue. And then your extension, if you dipped red and blue litmus paper into acid rain, what would you expect to happen and why? Red litmus paper would stay red and blue litmus paper would turn red because it's an acidic solution. So it's going to tell you acid rain is acidic. So what I would like to do is pause this video now. Make sure you have corrected anything you got incorrect, please. And then once you are ready, just press play. Okay, now we're going to move on to universal indicator in the pH scale. So, universal indicator is actually a mixture of several different indicators. That's why you can see it gives you a wide range of colors. It shows us how strongly acidic or alkaline a solution is, not just whether the solution is acidic or alkaline, like litmus paper. So it can tell you, ooh, be careful, this is very strong acid, it's pH 1, therefore it's corrosive. Maybe don't touch it. Be careful when handling it, for example. So these are important points that you need to know about the pH scale. Neutral solutions are pH 7 exactly. Acidic solutions have pH values of less than 7. Alkaline solutions have pH values of more than 7. The closer you go to 0, 1, the reason I put 0 is because sometimes some pH scales have 0 on them and some have 1 on them. So the closer to pH 0/1 you go, the more strongly acidic a solution is. So if you have a look at the diagram here, pH 1 is more strongly acidic than, say, pH 6, weakly acidic. Then the opposite way around, the closer to pH 14 you go, the more strongly alkaline solution. So if you have a look again, if you go to pH 14, this is extremely strongly alkaline, so it is corrosive. It is actually more damaging than a really strong acid. So we have a consolidation task here. Again, this is on the Teams Word document. You can't get onto it. Please do it on a piece of paper and then send me the picture as well. So you're going to set your time for 7 minutes again. You are going to then pause the video, write down your answers, and then after 7 minutes, come back to this PowerPoint, and then you're going to self-assess and mark it. Okay, so pause the video now, please. Okay, brilliant. So, solve the problems below. A bee sting has a pH of 6. Describe what it is. It is a weak acid. Remember, anything close to pH 1 is a really strong acid. As you go up towards 7, becomes a weaker acid. Human skin actually has a pH of 5.5. That is a weak acid too. Toothpaste has a pH of 9. So it is a weak alkali. Now, substance X has a green color when tested with universal indicator. What pH is it? Is it acid, alkaline, or neutral? So you want to say it is pH 7, which is neutral. Because remember, green color is pH 7, which is neutral. Substance Y has a pale yellow color when tested with the universal indicator. What pH is it? You want to say it is pH 6, which is a weak acid. Substance Z is slippery to the touch. So this is going back a few lessons to remember, what does slippery to the touch mean? And very corrosive. Describe what you would do to find out what type of substance it is and what you think it might be. Because in science, sometimes with the information you're given, you can make a prediction. You can be quite accurate with that prediction as well. So, slippery equals alkaline. Remember, anything slippery, soapy means it's alkaline. So we know substance Z is an alkaline. Very corrosive. That's telling you about the strength of the alkaline. So it's a very strong alkaline. So it's probably pH 13 or pH 14. So you would use a universal indicator to confirm this. So it would come up as a dark purple if it's pH 14, and you can go correct. So my estimation, it could be bleach or drain cleaner. So I think that's probably a good prediction. Now, you are going to watch a scientific inquiry. So an experiment. You're going to watch a scientist conduct a scientific inquiry. Again, the link to this YouTube video is on Teams. So when I finish explaining what you need to do, you need to press pause on here. You need to open up this YouTube video that's on Teams, which will have the name Scientific Inquiry. You need to watch it. Then you need to answer this question. How can the experiment in the video be used as a scientific model? Remember what a model is. To explain acidification of the ocean. So write your answer on the Teams document. Again, if you can't go into Teams, do onto a Word document and send me the picture, please. So I would like you to pause this video, open the other video, watch it, and then write down your answer, please. Okay, and then finally, the last task. This is a fit task, so if you can be in complete silence just to get you to concentrate really, really well. So answer the following question in a full sentence. I don't want bullet points. I don't want notes. It has to be a full sentence. Use really good English, please. Think about it. Capital letters, full stops, your grammar. So which indicator, Litmus or universal, is best to use on an unknown substance? Explain and justify your answer, meaning explain which one you would choose and why. Then write your answer on a Teams Word document. So pause when you're ready to do this task, and then once you have done the task, please submit it via Teams or send me a picture via my email. Okay, well, good luck. If you have any questions, please don't hesitate to either email me or put it in the Teams chat, and have a good day. Bye.